Hi students, today we will discuss one important concept now, that is moment of force, that is torque, or we can call it as like a rotational dynamics. So what is this torque or what is this moment of force now? See, if you want to make an object to move, that means like one vehicle is moving, one cycle is moving, one car is moving. So we require external force, therefore the object will be able to move forward onto this, right? So external force is required, make an object to move like a translator motion, no? So what requires an object to make it to turn? So therefore here not only the force is not sufficient onto this one, no, force and this perpendicular distance. So therefore if you are exerting the force onto this one, no, so what will happen now, this object it will be able to rotate like this. You are understanding? So therefore if you want to make an object to rotate, therefore we require compulsory the torque, right? So in our day to day lives now we are seeing our fan is rotating because the torque is acting on that one, no? So our wheel is rotating, no, our car wheel or right cycle wheel, no, so the torque is acting, making that cycle to rotate. Even simple, every time when we will open the door and we will close the door, no, so we are opening the door is because of due to the we are exerting the force at certain distance from the certain distance now, so that the door will be able to rotate like this, right? So therefore there also you are exerting the torque. So one simple thing, remember that is if an object want to rotate, you require torque, no, external torque. If an object want to be translate, so you require external force, right? So that we already studied that therefore for every rotational motion, you need to add momentum. Therefore like momentum is there, no, angular momentum, moment of momentum, right? So the force is there, no, moment of force, so which will make an object to turn or will make an object to rotate. Therefore how to calculate this moment of force now is a very simple one now. Therefore you can calculate the moment of force. So moment of force, or we can call it as like a torque, we'll denote it as like a tau. So this torque can be defined as like a force, right? You need to exert the force into perpendicular distance, right, from the axis of rotation. Clear? So therefore torque is defined as like a force into perpendicular distance. That means you need to exert the force. So on the door, no, therefore you are exerting the force, no, so that the door completely it will be able to move it onto this, right? So here there is a door is there, no, therefore here there is a hinges are there, no, so where it will be fixed onto this, therefore this it will be your axis of rotation now, right? So here only the door it will be able to rotate, so here you will exert the force onto this, you will exert the force here now, that means you will exert the force here, so that therefore this door, no, it will be able to move it and close it onto this. Clear? So therefore this force and you are exerting the force and the perpendicular distance, this distance now. So force and perpendicular distance, we will call it as like a moment of force, or there is nothing but a torque, right? So what is the unit for this one now? Force is nothing but a Newton, into perpendicular distance is nothing but a meter, Newton into meter. So therefore sometimes we will write it like joules, no? Joules is related to the energy, Newton meter is nothing but a torque. So what will be the dimensional formula? It is exactly like a energy, m1 L2 T minus 2. So like dimensional formula for energy, dimensional formula for torque, no, both are same, but both are, both quantities are different. So whether it is a vector or scalar, therefore it is a vector. Where is the axis of, where is the direction is acting now? It is acting along the axis of rotation, that's why you can call it as like a axial vector, right? So how to calculate the direction now? So very simple one now, you have to use, so to find the direction of this one now, you have to use right hand thumb rule. So you have to use right hand thumb rule, no, you have to use your right hand, therefore you need to curl the fingers like this. So in which direction the thumb indicate, no, so in that direction the torque is going to act now. So we will see in some applications onto this one, no, very simple, right? Let us see one simple concept now. Suppose here we are exerting the force here, right? Now we need to calculate the torque at this point, no? Therefore here it will be your position vector, no? Therefore this is your R to F, therefore R cross F, no? It will be acting into the board onto this one, no? In this way you can calculate the torque, no? Therefore here the torque can also be written as like a, what is the formula here now? Torque can be written as like a vectorially, that is nothing but a R cross F. Clear? Therefore this it will be the torque, no? Here it is going to exert the torque, no? The torque direction is what? This is R cross F, R to F, no? This is into this one, no? So therefore the torque is acting like this, so definitely it is perpendicular to this one, no? Perpendicular to this. Therefore torque is perpendicular to R and torque is perpendicular to F. Perpendicularity condition, you know it, no? In vectors, no? Torque dot R, it will be equal to 0, torque dot F, it will be equal to 0. So here we can rewrite it as the torque, no? Here, so torque is equals to R, therefore F into therefore R sin theta. Clear? So that is perpendicular distance or perpendicular force, no? You can rewrite it as R sin theta or R into F sin theta. That is nothing but either perpendicular distance or perpendicular force, no? Right? So when the torque will be maximum now? So torque will be maximum, right? Here, so torque will be maximum. So when it will be maximum now? Therefore, so when sin theta is equals to 1, that is nothing but theta is equals to 90 degree. That's what I said, no? Perpendicular. So what is the maximum torque here now? Maximum torque is nothing but R into F. Clear? Similarly, so when the torque will be 0 now? When the torque will be 0, so if there is no force is acting, no? And also therefore if it is R is also 0. R is also 0 means what? If a force is acting on the axis of rotation, suppose, so this is one rod is there, no? Therefore this rod is hinged at this point, therefore it is hinged at this point, no? If you are exerting the force along this hinge, no? Or along this axis of rotation, no? Right? So why? Because R is equals to 0, therefore torque it will be equal to 0. Even the force is there, but the force is acting toward the right, so toward the hinge onto this one, no? Right? R, so sin 0 it will be also equal to 0, sorry, sin theta is equal to 0, that means theta is equal to 0 or 180. That means if this is a door is there, suppose if you are viewing from top section, no? Suppose if you are exerting the force here, no? That means you are pushing the door like this. So this is your axis of rotation, you are exerting the force in this direction, no? So torque will not exert, it will not able to rotate. Or if you try to pull the door outside onto this one, no? Therefore in that case also torque will be 0 onto this. Clear? So one more important point, no? Therefore here if the torque is constant, so here if the torque is constant, no? So you can rewrite it as, no? One more point, no? Very important. So if torque is equals to constant, so what you can write it now? Therefore force is inversely proportional to R sin theta. That means if it is a R, you can rewrite it as R, force it will be equal to torque by therefore R sin theta. That means, so if it is smaller distance is there, no? You require larger force. If it is larger distance is required, that means R sin theta is larger, therefore force it will be minimum. That means you are having the door, no? Therefore this is a door here, no? Clear? So if you are this is your axis of rotation, no? Suppose if you are exerting the force here, if you are exerting the force here, the mostly the handles are kept here, no? So why the handles are kept at the corner, no? Because here distance will be larger, so that it will be able to move very easily with less force. But if you try to move here, no? Here if you want to exert the force, no? Here the force it will be maximum, more amount of force you have to add it. Why? Because this distance is smaller. If the distance is smaller, force will be more. If the distance between them is larger, force will be less. Right? So keep in mind this one, no? So about the force application, so that it will create like a torque, no? So now we will discuss one important concept, no? that is equilibrium. Very, very important. So compulsory question for JEE mains and NEET, no? Every time the question is coming based on this equilibrium. Equilibrium means what? So you need to remember that. So equilibrium immediately you should get into your mind. Therefore, it will not moving. Yes, sir? So if it is not moving means what? There is no translator motion. No translator motion means what? Therefore, total net force. So total net force acting on the system should be equal to 0. If the total net force is equal to 0, so then it's said to be like a translational equilibrium. So translational equilibrium. So means what? That means this object will not be able to move. It will not be able to translate it now. So suppose there is a one rod is there now. Suppose this one rod is there. Suppose this is one rod is there now. Therefore, here what we are doing now, we are exerting the force here now, same force no. Suppose F here now, therefore same force we are acting onto this. Same force. What is the net force here now? This side same force is there, this side also same force is there. So net force is 0, it will be under translatory equilibrium. But what will happen now? Try to observe this one now. You are exerting the force here now, you are exerting the force toward this side no. So therefore if you are exerting the force here now like this, what will happen now? It will be not moving, but what will happen now here now? It will be able to rotate now. You are exerting the force here, you are exerting the force here now. Therefore, what will happen now? This will not move from one point to another point, but what it will do? It will be able to rotate at this point. So here, so in this way, therefore this force is there, this force is there now, this rod now, it will be able to rotate. That means it's not translating, but it is rotating. There is a rotational motion is there. So to balance that also, we require, right? So in order to not to rotate, what should be there? Torque. Therefore, net external torque, the total external torque acting on the system should be equal to 0. So this is said to be like a rotational equilibrium. So therefore, if both of this one is there now, therefore translational equilibrium and rotational equilibrium is there, then the object will be said to be at equilibrium now, right? So that means total net force means what? Total net force should be equal to 0. Here total rotational motion, therefore total torque should be equal to 0. That means a clockwise torque and anti-clockwise torque no should be equal to 0, right? So we'll do these problems based on this also. So remember, so here total clockwise torque and therefore total anti-clockwise torque should be equal now, right? So how to find the clockwise and anti-clockwise now? We'll do some questions on this one. Clear? So now we can solve one. We can write one more formula for a torque. No, that is a torque can also be defined as like that force. What is the force formula? Mass into acceleration, or that rate of change in momentum. No, dp by dt. Similarly, exactly the torque. No, torque also can be defined as instead of mass here moment of inertia. Instead of acceleration, here angular acceleration. Here instead of momentum, therefore angular momentum dl by dt. Clear? So in this way, so we can rewrite it as the torque so is equals to moment of inertia into angular acceleration. Torque we can rewrite it as force into perpendicular distance, or it will be equal to I into alpha. And also we should know one relation here, no? So velocity and angular velocity relation, acceleration, angular acceleration relation, no? You should know it. Therefore, we know that here theta or L is equals to, or theta is equals to, so theta is equals to arc length by radius onto this one, no? Or L is equals to R into theta. Therefore, in circular motion we will discuss this concept, no? So if you differentiate it now, dl by dt, so d theta by dt. Therefore, velocity is equals to r omega. Again do the differentiation now, dv by dt is nothing but acceleration. So r is constant, d omega by dt is nothing but r into alpha. So these are the linear one now, these are nothing but angular one now. Therefore, linear and angular parameters now, in this way we can relate it now. Therefore, this equation, so we'll use most, and this equation we'll use most here now. Clear? So these are the two important things now we require to study in this concept now, that is torque and acceleration is equals to linear acceleration is equals to r into angular acceleration. Clear? Now we will do some questions based on this one now. Let us see one questions now. Right, we will do one question here now. So like a basic understanding question now. Later on we will go for some complicated one now. So this one question is there, this one rod is there, this one rod. Okay, so this rod is exerting the force here now, therefore it is about 60 newtons. How much force is there now? Downward force is there, that is 60 newtons now. Where it is acting at B? So I will tell you this one now, this is one rod is there now, like this, therefore here at this point B now, therefore here it is 60 newtons is there. So this is A, this is B, so this is C, this is 2 meters and this is 1 meter. Now we want to calculate the torque due to this force at point A, very important. So therefore here torque at A we want to calculate, therefore at this point A we want to calculate. So therefore at this point no, this force is acting. How this force, what it will do now, this force will make an object to rotate like this. Clear? So you have to use right hand thumb rule no. Therefore here this is your perpendicular distance no. This is your perpendicular distance. So this is nothing but a r cross f. That means this is making the to rotate like this. That means it is this force no, it is making to rotate like this. It is inside onto this. So suppose it is into this one. How it will be rotating no? It is rotating like this. So this is nothing but a clockwise. Clear? Now what you can write it now? Torque at A. So torque at A. So you can write down force into perpendicular distance. This is the rod is massless no. So here force is acting onto this. Therefore torque force into perpendicular distance. So very simple one now we can write down. Therefore here force is how much now? 60 into 2. Therefore 120. So Newton into meter. Therefore clockwise. Clear? So now what will be the torque at B? Is asking torque at B. At this point only, therefore it is acting on this one no. There is no r distance it is there no. Therefore force is there, but perpendicular distance is that is 0. Therefore torque at B it will be equal to 0. Clear? So now what will be the torque at C now? Torque at C. Therefore now you can remember now torque at C. So here this force, this point you are trying. So this force it will making to rotate like this. You understand? So it is rotating like this. That is nothing but anti-clockwise. So torque at C it is equals to force into perpendicular distance. Again perpendicular distance. So force how much now? 60 Newton. What is the distance it is given now? Distance is given as 1 meter no. Therefore 1. Therefore 60 Newton meter. Therefore anti-clockwise. Clear? So in this way you can solve the problems no. So very easily. The finding the directions is also very important. Now we will do one more question here no. Now here we want to calculate the torque at this O. Torque at this point O. Now this 10 newtons, what is doing now? This 10 newtons no. 10 newtons. Therefore here what is the perpendicular distance no? That is nothing but 4 meter. This 10 newtons what it will do no? This side perpendicular distance. Therefore it is making to rotate like this. Clear? So this is making to rotate like this. And this one, so this 20 newtons. So what is doing now? It is also making, it is at this point no. This also making to rotate like this. So these two are in the same direction no. But this 50 newtons, what is doing now? This 50 newtons no. This 50 newtons no. Observe this. It is making to rotate like this. This 50 newtons. So it is making to rotate clockwise. 50 newtons no. This 10 newtons and 20 newtons making to rotate upward onto this. Clear? So we want to calculate the net torque no. So net torque, how to calculate it now? So therefore torque due to A plus torque due to B plus torque due to C, vectorially you have to add. So this one we want to calculate the torque at O. Right? Torque due to at A. So at A, therefore suppose this is 10 newtons no, at A. This is A, this is B and this is C. So therefore torque at A is how much no? This is 10 and perpendicular distance is nothing but 4 meter. So 10 into 4. So it is in the which one now? Anti-clockwise. Therefore anti-clockwise. So AC, right? So now torque due to B 20 into 4 again anti-clockwise, but here so torque due to C, the C is making to rotate like this, no? Therefore 50 into 4, this it will be the torque at O, this is clockwise. So anti-clockwise both are added 40, so this is 40 plus this is 80, so this is minus, this is 200. Therefore here it will be how much, no? 120 minus 200. Who is dominating now? Therefore clockwise is dominating now. Torque at 0. So torque at O it will be equal to minus. So minus. So therefore 80. Therefore Newton into meter. That is nothing but a clockwise. Right. So therefore it is making, this is your anti-clockwise, no? So then you can take it as like a torque at O, it will be equal to 80 into Newton meter into clockwise. Clear? So in this way you can solve the problems, no? So related to this. Now we will do one more question here, no? So slightly very important question here, no? So most important, no? Right. You try to understand this one, no? A uniform rod is there. This is one rod, right? This is one rod is there, no? Right. So what is the mass of the rod, no? 20 kg. 20 kg. Uniform rod means where it will be there, no? It will be exactly midpoint. This is total distance is L. L by 4 it is given, no? Therefore, total distance is L means this is totally it will be L, no? So that means uniform rod means it will be L by 2 distance. How much now? 20 Newton. 20 G. That means nothing but a 200 mg. That is nothing but a 200 newtons. Because the weight, that is center of gravity. So every object it will be having the center of gravity, no? This rod, the total weight, no, weight of this rod, no, is acting at the center of gravity onto this. And along with this one, now, what we are doing now, we are adding some weight here now. What is that weight now? So 40 kg, that means nothing but a 400 newtons. What is the distance here now? L by 4 distance. Clear? This is L by 4. Here already 200 newtons, that is 20 kg it is given now. Clear? 200 newtons. So we have to calculate the tension developed in the strings, no? That is the tension in this one, no? This, therefore tension T1 and suppose T2, no? Now, if you want to calculate this type of questions, no, very easily. So first you have to write downward force and upward force, no, like that also equal, no, are very simple one, no. So calculate the moment of torque at any one of this point. Suppose at this point A we want to calculate the torque. So at this point what we will do now? Here this 40 kg what is doing now? This 40 kg making this to rotate like this, and this 20 kg is also making to rotate like this. And this tension in this one, now this is T2, it is making to rotate like this. So this T1, therefore torque due to T1 is 0. Why? So torque due to the T1 it will be the 0, not T1 will be 0. So therefore torque due to tension T1, no, it will be 0 because it is acting at this point. If you are able to write this total torque equations, no, it is very simple to write it, no. Let us write down this one now. Therefore this is 40 kg means 400 into perpendicular distance. What is the perpendicular distance now? L by 4 plus this 20 kg also 200 into L by 2. Why? Because this is at the center, no? And this is your two torques are there, and this is another this is your anti-clockwise, these are the clockwise torques now. So equilibrium, it is not rotating anywhere, no? Therefore equilibrium, total clockwise and anti-clockwise torques will be equal now. Therefore this T2, what is the distance here now? This T2. Therefore T2 means what is the distance? Total L now. Therefore here it will be 100, here it will be 100. So L taken common now. Therefore 200 L now. T2 it will be equal to 200 newtons. Clear? So T2 I got it how much now? 200 newtons. Right? So T1 is how much now? Total downward force is how much now? 200 plus 400, therefore 600. Upward is already I got it as 200, no? So compulsory this one it should be equal to 400 newtons now. Right? Sir, I want to check it. This one means what? What you have to do? So again, you try to find the torques at this point, no? So therefore, this 200 will make it to rotate like this, 400 will make it to rotate like this, T1 will make it to rotate like this. Then you can able to solve the problem very easily. Clear? Now we'll solve the problem here, no? So one more question here, no? Right. Now there is a weightless rod is there. This rod is weightless. Weight is not there now. Right? Is acted upon by the two upward parallel forces now. What are the forces now? This side is 2 newtons, this side is 4 newtons. At the ends, the total length of the rod is 3 meter. Very good. To keep the rod is under the equilibrium, therefore 6 newtons should act in the following manner. That means here 2 upward forces are there, compulsory 6 newtons should act at the downward onto this. So we want to calculate from the end AC, right? So is again same thing, no? So therefore here 6 newtons should act on. Where is the distance? No, this distance we can take it as x, no? X is given, this total distance is 3, but here in between these two is nothing but x is gone, no? 3 minus x, no? We want to calculate this x, no, here. So therefore again the same thing, then you can take this as your any not only here, no, here also you can take it as your axis of rotation, no. Suppose if I am taking it A, so as your axis of rotation, these 2 newtons will not create any torque, no. This 6 newton will create the torque like this, this 4 newton will create the torque like this. So we can rewrite it as, so 6 into perpendicular distance how much, no? 3 minus x should be equal to 4 into, so this total distance is nothing but a 3. So therefore 3 minus x is equals to 4 into 3 by 6, no? So 3 2s are therefore 2. So therefore 3 minus x is equals to 2. So therefore x is equals to 3 minus 2, x is equals to 1 meter. Therefore from the B end, so here it should be equal to 1 meter and here it should be equal to 2 meter. So downward at any point between A and B, wrong answer. So downward at a point midpoint is not possible because it is 1.5. So downward at point C, so that AC will be equal to AC is nothing but 2 meter, this is also wrong. So downward B, D option will be your correct answer. Clear? Now we will see one more question here, no? Exactly the same way. So like what we discussed in the a uniform rod is there, no? Therefore of total length is L. Its mass is M. Therefore rod is there, no? Its mass is M. Mass is M means what? Definitely it will act downward. It hangs by the 2 strings, no, of equal length from the ceiling as shown. Determine the tension in the strings. Okay. So here therefore what happened now? Therefore total only mass M is there. Where it will act now? Mass M, definitely it will be L by 2 distance now. Therefore it will be act here now. Downward it is nothing but a mg. Clear? So if you want to calculate the tension here, no? So T1 and T2 tension, no? So again the same story you have to write it, no? So you can calculate the tension, so make an axis of rotation at this point, no? So this M1 mg it will act like this distance is L by 2 and this tension, no, T2 will make it to rotate like this. Clear? So now we can rewrite it as mg into L by 2, this is downward making like a clockwise movements and anti-clockwise. This T1 will not create any torque, no, because passing through the at the end of this one, no. Therefore here T2, so where is the distance now? 3L by 4, that is 3L by 4. So therefore L and L get cancelled, it is 2. Therefore T2 it will be equal to 2 by 3 mg. I got T2 as how much now? 2 by 3 mg. So total downward force is how much now? mg. T2 is how much now? Is upward. So similarly you can write down T1 plus T2 is equals to mg. I got T2 as how much now? T1 plus 2 by 3 mg plus, sorry, it will be equal to mg. Therefore, T1 it will be equal to mg. So, 1 minus 2 by 3. So, T1 is equals to mg by 3. So, T1 value and T2 value, in this way you can calculate it now. Clear? So, now we will do one question now. Here there is a rod of mass m is there now. M and length is L. It is released. Find out the alpha just after releasing now, right? So, here there is a one rod is there now, like this is one rod. So, suddenly what you are doing now, therefore we are releasing now, we are releasing. Therefore, what is happening now? It is falling down. Why it is falling down now? No, because there is a gravity is acting here now. This gravitational force which is there now, it is making to rotate like this. You are understanding? So, here where it is rotating now? Here it is rotating now. Therefore, this is the hinge is there now, it is rotating. So, which is force is making now to move now? Therefore, this is mg. So, where it is acting now? It will be about L by 2 because it is a uniform rod onto this. So, here what we have to calculate? We want to calculate alpha here now. So, releasing, after releasing now. Therefore, first of all, what is the torque acting now? Torque is nothing but a force into perpendicular distance. Perpendicular distance is equals to, therefore, I alpha. Clear? So, force how much now? mg into perpendicular distance is how much now? L by 2. I is the rod is there now. Therefore, this rod, what will be the moment of inertia of the rod at the axis passing through the one of its end now? Therefore, ml square by 3 into alpha. Right? This m and m get cancelled out now. 1l get cancelled out now. So, therefore, alpha is equals to 3g by 2l. So, will be your alpha onto this. In this way, you can calculate the alpha in this situation. Now, let us see here now. Therefore, this same type of question now. So, this is this also one rod is there now, rod of mass m and length is L is released. So, again it is released now, it is released. So, find out the acceleration of the marked points which are equidistant of each other, like this is D, these all are equidistant now. Equidistant means what? Total length is about this is one rod is there now. Therefore, here it will be hinged at this point now. Therefore, this is D, right? And this point is D. So, this point is A, this point is B, this point is C. All are equidistant. Total distance is how much? Total length is how much now? Total length it will be equal to L. So, 1, 2, 3, 4, 4 no. Therefore, L by 4, L by 4. So, L by 4, L by 4. The distance between them now. Now, if it is released now, if it is released, each and every point will be having the same acceleration onto this. Right. So, we want to calculate the acceleration of this point at this point no, and acceleration, linear acceleration now, not angular acceleration. You see, whenever there is a rod is there now, if it is released now, therefore, it will be having angular acceleration. What is angular acceleration now? We already calculated in a previous question now, alpha is equals to, so angular acceleration it will be equal to 3g by 2l, right. So, previously we calculated no. Now, we want to calculate linear acceleration. What is the relation here now? Linear acceleration. So, acceleration at D, and this acceleration at point D now. Therefore, here acceleration at D. So, what you can write it now? R into alpha. What is R? Perpendicular distance now. Therefore, it is L by 4 into 3g by 2l. Get cancelled no. L get cancelled. 3g by 8. So, will be your acceleration at the point D. So, similarly, acceleration at point A, we want to calculate again the same no. Therefore, what is R here now? L by 4 plus L by 4. Therefore, it will be L by 2 into 3g by 2l. Therefore, it will be 3g by 4. So will be your acceleration at A. Similarly, acceleration at B and acceleration of C. So please calculate it, right, and comment in the video now, right. So same here we can solve the problems now, right. We'll solve the problems now. Here problem. So we have to calculate, find the alpha of this rod now. Alpha means torque is equals to force into perpendicular distance, and it will be equal to therefore I alpha. So force, which force is responsible here now? You try to observe this one now. Only mg is the force is there now. Mg, what will be the perpendicular distance now? This is your point of suspension now. It will be hinge at this point now. This distance is L by 4. Now the moment of inertia at this point now. Therefore, how to calculate now? Let us see. This is one rod is there now. This is one rod. So this rod, it is a uniform rod now. So here at the center of this, at the midpoint of this one now, this it will be your Ig. Ig is how much now? ml square by 12. Here we want to calculate at what distance now? At L by 4 distance now. This distance totally it will be L by 2 and this distance is L by 4. So this is here you have to calculate. How to calculate now? You have to use parallel axis theorem. So parallel axis theorem I already discussed in moment of inertia. So part 2. So please go through it now. So here parallel axis theorem is what? I is equals to Ig plus md square. Ig is how much now? ml square by 12 plus m into, what will be the distance here now? This distance is L by 2. This distance is L by 4. This distance is also L by 4. So it is L by 4 whole square. Clear? So how much it will be? ml square by 12 plus ml square by therefore 16. Or so you can write it as ml square by, therefore here you can write on 4 taken common now, 1 by 3 plus 1 by 4 here. Therefore here you can rewrite it as this is ml square into 7 divided by 12 into 4. Clear? So this is your moment of inertia. So 7 ml square by 12 into 4 into alpha. So here 4 and 4 get cancelled out now. 1 L get cancelled out now. M and M get cancelled out now. So here alpha is equals to 12G by 7L will be your alpha in this rod now. Clear? In this way you can calculate the alpha of this rod. So we will discuss one more problem now. This is one pulley problem is there. We did this pulley problems now in Newton's laws of motion. Also I did one video on the shortcut method onto this one now, how to calculate the tension and how to calculate the acceleration. But there what we considered now, we considered that this pulley was ideal. This pulley was ideal. Ideal means massless. But here what we are going to consider now, therefore here mass of this pulley is given onto this one now. Therefore it is not massless now. Then therefore to rotate this one now, to rotate this wheel also certain amount of force it will be needed onto this. So therefore if you are including the mass of this pulley, then how to solve these problems now? Let us do one simple concept now, simple one now. So let us see here now, downward force. What is the downward force now? That is nothing but a 2 mg is the downward force. So due to this one now, tension is nothing but a suppose T1. Now due to this one now, this force is how much now? mg. Due to this one now, tension is T2. Right? Here tension is not same onto this one. Now therefore here what we are going to do now, we are going to rotate this one now. Therefore this one, what it is doing now, this tension now, it is making to rotate like this, and this tension now, it is making to rotate like this. Clear? So therefore in which direction it will rotate now? This side is heavier mass now. So this side torque was more, that's why it will be able to rotate in this direction. You have to consider this rotational of this one also, you have to consider torque of this one. Then suppose it is going downward with an acceleration and it is going upward with an acceleration. We can write down the equations now. What is this equation now? Downward, that is nothing but a 2 mg minus T1 is equals to 2ma. We already studied free body diagram now, how to write it now in Newton's laws of motion. Now here we can write it now, this side is going means T2 is greater, so T2 minus mg, it will be equal to ma. Not only this one now, therefore we need to write it here, this torque. What is the torque here now? This T1, what it is making now, making to rotate anti-clockwise. This T2 making to rotate in clockwise. Net torque is how much now? Net torque no. So force into perpendicular distance. So therefore T1 into force into perpendicular distance no, into therefore R. Where it is a perpendicular distance, this distance is nothing but a R. Radius of this one no. Minus T2 into R. So torque, net torque no. So net torque no, that is nothing but a I into alpha. Clear? So therefore what you can write it now here, T1 minus T2, so into R, it will be equal to moment of inertia into alpha. Alpha is, we can write down, A is equals to R alpha. Therefore alpha is equals to A by R. Sorry, here no, this is R, we have to write it. This is R, right? So we know these equations no, therefore these two equations we know it no, therefore we can calculate T1 minus T2 in this one no, T1 minus T2, then you can eliminate into this one no, then you can solve for acceleration onto this one no. Clear? So you can solve these three equations no, therefore so these three equations you can able to solve it no, but I will give one simple trick for this one no, very easily you can calculate it onto this one no. So first, what is the trick here no? Trick, very simple formula, acceleration. What is an acceleration here now? Acceleration is nothing but a total mass by total force by total mass. So what is the total net mass, net force here now? Downward force is total net force is how much now? Therefore it will be 2 mg. So therefore 2 mg net force, that is we can write it as directly, so net force by therefore total mass of the system. So what is the total net force now? Here downward force is nothing but a 2 mg is there no, and this also acting, right? Both are acting, therefore so what you have written now? Therefore this both are acting onto this one no. So you need to total net force how much now? This side it is pulling on, this side is pulling onto this, minus therefore it will be mg divided by total mass of this one is how much now? Total mass. So therefore here, why minus no? Because this is making this to rotate here no, this is making to rotate here no, therefore this is making different acceleration like this, therefore total net force onto this one it will be here, right? Actually here this total 2 mg plus mg it is acting upward, but here we are making to rotate it no, this is trying to make toward this side, this is trying to make toward this side, that means both are acting in opposite direction, that's why we written as minus here now. Therefore total mass is how much now? Therefore it is 2m plus m plus due to moment of inertia of this one now. So therefore you can write down moment of inertia nothing but m r square, m is equals to I by r square. So I by r square. So this is your formula, you can rewrite it as, so this formula you can get by solving these two, you can calculate the problems here now, right? If you remember this formula is enough. How I got it now? You solve these two equations, you will get this formula only. Now we will write it now, we will simplify this question here now very quickly. Therefore here, so what is given now? Here it will be 2 mg minus mg is nothing but a, so mg by therefore 3m plus what is this one now? We will take it as like a disc no, disc, right? This wheel, right? So this will take it as this. Now what is the moment of inertia? Moment of inertia is nothing but a mr square by 2 this disc no. So therefore I by mr square means is nothing but a m by 2. Clear? So how much will get it now? mg, therefore it is 6 plus 7, 7m by 2, it is into 2, therefore you will get cancelled, therefore 2g by 7 will be your acceleration, so of this problem now. You understood no? So therefore how to solve these problems no? So very easily, so remember this formula, so then you can able to solve the problems very quickly onto this. Clear? So how I got this formula? By solving these two, right? Now we will solve one more problem here no. Okay, same type of question no, similar type. So here right. Same type of question here, no? So therefore here you will take it as mass m, here it is mass 2m, this also suppose it is m only, okay, you take it as m only here. Find out the acceleration of the blocks. So therefore here this same string, no, same acceleration will be there, but a different tension. Why? Because this wheel, whatever this, no, this wheel, no, it is given certain mass, not ideal one, no. If it is ideal, simple, our Newton's laws, no, you can solve these problems, no. Again, just now I taught this question, no, I taught this formula. So similarly, you can able to solve this concept now. Therefore, what will be the acceleration now? So total force. What is the total force here now? Therefore, sorry here now. Right, what is the total force here now? Total force is nothing but a mg sin 30. So therefore, mg by 2, this side force, no? This side force is nothing but a 2 mg. Which is greater now? This is greater. So that means, so this side force, no? Then you can, this it will go to here now. Therefore, how you can solve this problem now? Total force is nothing but a 2 mg minus mg by 2 by total mass of this. No? Total mass is how much now? 2m plus m plus moment of inertia. We can take it as like a disc, no? We can take it as like a disc here, no? So I is equals to mr square by 2. I by mr square is nothing but a m by 2. M by 2. That's all. You can solve this problem now. This is 4 minus 1. Therefore 3 mg by 2. Clear? So this is 3 mg. Therefore 6 plus 1 7. 7 m by 2. So m by 2 get cancelled. 3g by 7 will be your acceleration. In this way, you can solve the problems very easily by using this formula. Clear? Right? We will see one more question now. So here this is one of your JEE main question, no? JEE mains, right? So a particle of mass m is thrown up, right? We are throwing up, no? With an initial speed of u, making an angle theta with the horizontal. Find the torque of its weight. That means weight is nothing but mg. So about a point of projection and when it is reached to the highest point. So therefore here we want to calculate here now how it will be. It is like a projectile motion now. Therefore I already discussed this projectile motion no concept no. Please go through it, this concept no. So already we discussed the theory onto this. So go through it. So now let us see here now what will be the torque. Therefore torque at a highest point now. Therefore at highest point. Therefore at this point what is the force is acting now? Therefore force is acting downward like this no. So downward is nothing but mg. So this is the torque no. Therefore what will be the perpendicular distance at now at the maximum height no? That is nothing but a r by 2, half of this range no. Clear? This is a torque which is created at this point. So what is the torque formula? You can write it no. Torque is equals to force into perpendicular distance. Force into perpendicular distance. Clear? So force is how much now? That is mg into r by 2. So what is the maximum range formula? Right? Range formula is nothing but a, therefore u square sine of 2 theta by therefore g. Clear? So therefore here what you can write it now? Therefore mg into mg by 2 into u square sine of 2 theta by therefore g get cancelled out no. This g get cancelled out no. So therefore m u square sine of 2 theta by 2. Okay, therefore here you can rewrite it as sin 2 theta can be written as mu square into 2 sin theta cos theta divided by 2. These two also get cancelled out no. Mu square sin theta cos theta will be your answer onto this. Clear? So therefore here mu square sin theta cos theta no. So this it will be your answer. Clear? Right? So now we will go for one more question no. So this is your net torque. Right. find the torque about point O. This is slightly important, no? You need to understand, you will get the clarity on this torque here, no? Therefore, here we have to calculate the torque, no? So, which are acting in our direction, so that should be added, which are acting in opposite to the direction, no? That should be subtracted, no? Clear? So, here to see the clarity onto this one, no? So, we will go for bigger one, no? Right. Now, so which are acting in our direction, like in one clockwise, all clockwise torques, no, can be added, all anti-clockwise torques, no, can be subtracted. So, this F4, what it is doing now, F4, therefore F4, right hand thumb rule. So, therefore, it is coming out onto this, right. So, it is making to rotate like this. Therefore, so due to 4, right, F4, it is coming out means you can write down K cap, clear. So, right, F4 value is like a 4 newtons, right. So, this F4 is making outward onto this one, no? This F3, okay, suppose this is your F3, 10 newtons. So, it is exerting like this, it is inside. Therefore, so torque due to F3, therefore minus K cap. So, F2, therefore it is exerting the force like this, no, it is outward. Therefore, torque due to second, therefore it is K cap plus this is acting along this direction now, therefore this will not create any torque onto this one now. Torque due to 1, it will be 0 here now, therefore it will be equal to the net torque about O, clear. So, therefore net torque about O, so we need to add like this, that means, so fourth one and second one we have to add, third one we have to subtract it now. We will calculate torque of due to fourth, torque due to 4, therefore force is how much now? 4 Newton into perpendicular distance is 1 meter. So, 1, therefore 4 Newton meter in K cap. So, torque due to 3. So, what is given now? This T. So, this is making an angle of 37 degree. So, 37 degree like this, no? Therefore, what I will do now? I will split like this, right? So, therefore, I can rewrite like this, no? Therefore, this is your 1 3 and this is here like this, right? So, this is your right opposite, no? Therefore, it will be the sin theta. Clear? So, F3 sin theta. Therefore, so 10 into sin 37 degree into perpendicular distance is nothing but a 2. So, this force, this cos is there, no? That cos is acting along this direction, no? So, that is why, so this will not create any torque, no? Only this force, no? It will create a torque on this. Clear? So, therefore, we know sin 37, you know this triangle, no? Therefore, here this is 37, therefore, this is 3, 4 and 5. Sin 37, this is here 53. Sin 37 means what? Opposite side by hypotenuse, no? Means 3 by 5. So, therefore, 10 into 3 by 5 into 2. So, get cancel out, no? Therefore, it will be 4 into 3. So, 12, but it is minus K cap. Minus K cap. So, therefore, now we can rewrite it as, so F2, therefore, this is F2 is there. Now, we can split this one, no? So, here this is your one force, no? This is your force. But this force is acting along this line, no? This will create the torque, it will be equal to 0. This only it will create the torque now. Torque due to third one, no? Sorry, second one, no? Torque due to second one, no? Therefore, force how much now it will be? So, this is your opposite side, no? Therefore, F2, therefore, this is your sin, no? So, F2 sin theta. Therefore, 5 into sin 53 into perpendicular distance how much, no? 3. How much it will be? 5 into sin 53 is how much, no? 4 by 5. 4 by 5 into 3 get cancelled out, no? Therefore, it is 12. So, therefore, it is K cap. Clear? Why? Because it is K cap. Then you can add up all these one, no? Because torque due to this one, no? Due to F1, it will be equal to 0. Why? Because acting along this one. No? So, now net torque, no? Total net torque is how much now? Net torque, no? So, torque at O, therefore, this is how much, no? 4 minus 12 plus 12. So, therefore, 4 Newton meter in K cap. 4 Newton meter in K cap. Therefore, fourth option will be your correct answer now. Clear? So, in this way you have to solve the problems related to the torque, no? Right. So, we will see one question now, very important question here now. So, this ladder is at rest, therefore, this ladder is at rest now. So what should be the minimum value of mu so that the ladder will be under equilibrium. Equilibrium means it's not falling down onto this, right? Not rotating. Here this side is smooth surface, this side no, this side it is rough surface no. We want to calculate this mu value. How to calculate this mu value now? Let us see now. So here under equilibrium means total force and total torque should be equal to 0. First let us balance the total force now. Total net forces now should be equal to 0. So what are the total forces now? Downward forces and upward forces both should be equal. What is the downward force now? Here therefore mg will be your downward force, mg, right? And this side it will be your upward force no. So there is, apart from this there is no other forces. Here there is no components here no, because of smooth onto this. So therefore n1 will be equal to mg, clear, right? And horizontal forces, what is the horizontal forces now? This side force is nothing but a frictional force no, this side force is nothing but a n2 force, right? So therefore n2 should be equal to nothing but a frictional force, clear, right? So first we got the balancing of the forces now. Now we have to balance the torques. So it is under equilibrium means what will happen now? Therefore here whatever the forces are there no, or whatever the torques are there no, therefore that also should be equal to 0. Now we will calculate the torque at this point no, at this point, at point A. What is the torque now? So what at this point no, therefore this n1 is acting along this point no, therefore n1 will not create any torque onto this, clear. So therefore this n2 what it will do now, and this frictional force also will not create any torque no, because it is also acting at this point. So this n1 will not create any torque no, frictional force will not create any torque no. Which one will create the torque no? This n2 will create the torque, clear. So and also this m1 mg is there no, this it will create the torque here no, clear. So we will calculate the torques at this point no. So torque at A, right? So total torque at A should be equal to 0, because it should not create any external torque here now. Therefore this torque at this point here no, therefore what will be this one now? This n2, what will be the distance here now? This distance, right? So n2, okay, so perpendicular distance no, therefore this is your distance now, right? So suppose this total length is L, this perpendicular distance is nothing but a, so this is your opposite side no, therefore this is L sin theta and this it will be your L cos theta, clear? Yes or no? Therefore n2 into, therefore n2 into perpendicular distance is nothing but a L sin theta, so it will be equal to, therefore mg, therefore mg, so this distance we want no, therefore here this is L by 2, this distance is also L by 2 cos theta, this total distance is L cos theta, but in that half is there no, that is nothing but a L by 2 cos theta, therefore L by 2 cos theta, clear. So this L and L get cancelled out no, therefore n2 can be written as, so mg into cos theta by therefore cos theta by therefore sin theta, clear. So in this way therefore we calculated the n2. So n2 means here frictional force is there no, frictional force is n2, that's all. So therefore frictional force should be greater than or equal to, therefore this is n2. So n2 we got it no, therefore mg into therefore here cos theta by sin theta, clear. So frictional force what you can write it now, this what is the normal reaction at this point now, therefore mu into, so mu into n1, but n1 you know it now, mu into mg, so therefore mu into mg, therefore finally we can write down mu into mg should be, right, minimum value is said no, therefore minimum value should be equal to, so therefore mg into cot theta, clear. Mg and mg cancel no, sorry here no, therefore here L by 2 is there, therefore this is by 2, so this is by 2, therefore here it will be the by 2, that implies here mu is equals to cot theta by 2 will be your answer, therefore cot theta, second option will be your correct answer. In this way you can solve the problems of the ladder problems no, just to create every time equilibrium means total torque should be equal to 0, total force should be equal to 0, that's all, clear. Now we will see one question here now, right. There is a disc is there no, this is a disc no, therefore find the angular acceleration of the disc. Angular acceleration. Angular acceleration means what you have tried it, no? Torque is equals to force into perpendicular distance. It will be equal to I alpha. That's all. Right? What is the force here now? Mg. Mg. Perpendicular distance is nothing but R. So disk is there, no? Disk now. Here very important. Where the disk is rotating now? At this point. Therefore, we already studied this is a disk, no? Therefore, we want to rotate at this point. That is, this is a tangent perpendicular to the plane. So how to calculate? Already I did moment of inertia. So theorems and all these one, no questions. So please go through that. I will keep this in a icon onto this, right? So here we want to calculate the moment of inertia. Here we can write it as Ig. So this is your Ig. So this one now parallel, no? So Ig is nothing but mr square by 2 plus mr square. How much now? It will be I is equals to Ig plus md square now. mr square by 2 plus m into r square. Therefore 3 mr square by 2. So what you can write it now? 3 mr square by 2 into alpha. Angular acceleration only, no? Therefore m get cancelled, 1r get cancelled. Alpha is equals to 2g by 3r will be your alpha. Clear? So in this way, a simple question, no? Therefore you can calculate it, no? Very easily. Now, a rope is wound around a hollow cylinder, right? Hollow cylinder, so of mass 2 kg and radius is this one now. If the rope is pulled with a force of 80 Newton, find the angular acceleration of the cylinder, right? So this also, right, a simple question, no? So this is one cylinder. Assume that this is a cylinder now, right? Upon to this cylinder, therefore what we did now? So we are wound. Therefore there is a one rope we are wounding onto this one. This is what hollow cylinder. Hollow cylinder means what? Hollow cylinder means immediately you can get it in your mind. That should be a ring. So hollow cylinder is nothing but a ring. What should be the moment of inertia here? No, moment of inertia is nothing but a mr square. Clear? So here this force now. Now this force is nothing but how much now? It will be 80 Newton. This force, what it is doing now? It is making to rotate like this. As we are pulling onto this, we are making to rotate like this. Clear? Now here we can rewrite it as, so this force, torque is equals to force into perpendicular distance is equals to therefore I alpha. Clear? Angular acceleration only is asking. Very simple one. No? Force, how much now? Force is nothing but 80 Newton into perpendicular distance. What is the perpendicular distance now? Where we are acting. Therefore, suppose this is your cylinder. No? You are exerting the force here now. Where? Therefore, at the radius distance now. Therefore, radius is how much now? Radius is nothing but 0.5. 0.5 means 1 by 2. Moment of inertia is how much now? Mr square. M is how much now? 2 kg. Therefore, here 2 kg and r square is nothing but 1 by 2 whole square mr square into alpha. Therefore, here it will be how much now? 40. So 40 is equals to, therefore here it will be, so 2 into 1 by 4 into alpha. Therefore it is 2. That is nothing but alpha is equals to 80 radian per second square. Fourth option will be your correct answer. Clear? Now we will see one more problem now. Right. Here there is a wheel is there. This wheel is, therefore wheel is having moment of inertia directly is given. Moment of inertia is how much now? 2 into 10 to the power of 3 kg meter square. Is rotating with an uniform angular speed. Therefore, initial angular speed is how much now? 4 radians per second. So what torque is required to stop it is in 1 second. That means time is given how much now? Time is equals to 1 second. Stop. That means final angular velocity is 0. So we want to calculate the torque now. We can use the formulas, that is nothing but a. So V is equals to U plus AT. Similarly, final angular velocity is equals to initial angular velocity alpha into T. It is 0. So therefore it will be 4 plus alpha into 1. Therefore alpha is equals to minus 4 radian per second square. This alpha I got it, no? So what will be the torque, no? Torque is nothing but I alpha. I how much now? 2000 into minus 4, therefore minus 8000, so Newton into meter. So 8 into 10 to the power of 3, therefore 8 into 10 to the power of 3, it should act in the opposite direction so that it will be able to stop. Clear? Now, so this is also one important question, no? Clear? Now let us see, there is a string is wrapped around this one, no? So around the disc, this disc is that disc, right? Acceleration of the block, therefore suppose this is your 2 kg. Okay, this is 2 kg. Therefore, here this disc mass is about m. No? We don't know mass. Okay, we want to calculate the acceleration. Acceleration means what you have to do now? Downward force, no? Therefore, 20 Newton. So 2g, right? So tension is T. Therefore, it is going downward with an acceleration is A. So what you can write it now? 2g minus tension. It will be equal to 2 into A. We want to calculate A. Clear? So then this tension, what it is doing now, it is making to rotate here now. Here asking tension and acceleration. Okay, this tension also we have to calculate. Okay. So therefore here we are creating the torque. No? Torque is nothing but a force into perpendicular distance. So tension into perpendicular distance is nothing but a, so therefore its radius is, we don't know what is the radius, right? Radius will take it as like a r, right? So therefore here force into perpendicular distance into I alpha. I alpha is how much now? It is a disc, no? Disc is nothing but a, so mr square by 2 into alpha. We don't want alpha. Alpha you can write down A is equals to r alpha. Therefore tension into r is equals to mr square by 2 into, therefore alpha is nothing but a by r. So taken here, no, tension, so into r square is equals to ma by 2 into r square. Get cancel out, no. So tension I got it, no. Therefore tension you can write it as ma by, therefore ma by 2. Okay, A I don't know. Therefore substitute this tension, no. Tension in this one, no. 2g minus tension is nothing but ma by 2, it will be equal to, therefore here it is 2 into A only we want to calculate, right? In this one now, this is not 2 kg, so therefore here it will be the, this is 2m, it is 2m. Therefore I can rewrite it as, this is this equation, no. I can here I can write down, therefore 2 mg, therefore 2 mg minus tension it will be equal to, therefore 2 ma. Clear? So therefore here you can rewrite it as how much now? 2 mg minus ma by 2, it will be equal to 2 ma. Taken here, no. So 2 mg is equals to 2 ma plus ma by 2, how much it will be now? This is 4 plus 5. So 2 mg is equals to 5 ma by 2, get cancel out, no. Therefore A is equals to 4g by 5, 4g by 5. Okay, so this is your, got it, no, 4g by 5, no. So tension we want to calculate. So this is your tension, no. Tension is nothing but a m into m by 2 into A is nothing but a 4g by 5. Therefore it will be taken here, no, 2 mg by 5. So this is 2 mg by 5. Like this you have to solve the problems now, right? Here also we can use that formula, our formula very quickly you can able to solve it, no. Let us see. So how to solve these problems very quickly, no. This acceleration instead of this one, no. So we already solved, we already told one problem here, no. So what is this one? Acceleration, total mass, total force is nothing but a 2 mg is a downward force. Total mass is nothing but a 2m plus this is a disc, no. So disc is nothing but a I is equals to mr square. So therefore it will be m. So what is this? It is a disc. Disc is nothing but a mr square by 2. So disc is nothing but a mr square by 2. So therefore it will be m by 2. So what you can write it now? This is 4 plus 1 5. So taken here, no. Therefore 4 mg by 5m get cancelled out, no. 4g by 5. So like this you can solve the problems very easily. Clear? Clear? So in this way you can solve the problems very quickly. Clear? So here we will do one more question here now. So a pulley is there now, a fixed pulley, right? Of radius is given. This radius is 20 centimeter. Moment of inertia is also given now. About an axis, massless string is wrapped now. A 2 kg mass is there. This is about 2 kg. It is given now. So is attached to the end. The pulley can rotate about its axis without any friction. Find the acceleration of the mass. Just now we discussed the problem now. So it is exactly the same way. Therefore, here we can write down very quickly. Total mass, total force is how much now? 2 kg. 2 kg means nothing but 22 G. Clear? So total mass, therefore this mass is nothing but so this mass is nothing but 2, and this mass, what you can write it now? Moment of inertia. So this is what moment of inertia is there. Therefore it is 0.32, but I by r square. I by r square value. I is how much now? 0.32 divided by r. R is how much now? 20 centimeter. 20 means 20 into 10 to the power of minus 2 whole square. Therefore 0.32 into, so 4 into 10 to the power of minus 2. Therefore taken here now 32 by 4. How much it will be now? 4 right here 4 right 2 16 8 right. So what you can write it now? It will be the 8. So how much it will be? 20 divided by, therefore 10, therefore 2 meter per second square. So 2 meter per second square. Like this also you can solve the problem very easily. Clear? So one more problem now, final problem now, we'll see. Right? So here there is no slipping is present inside in between this one, no, between pulley and the string, no. Therefore we have to calculate tension T1 and tension T2. Suppose this is T2. I think this is 2m, I think. Okay, 2m we will take it. Okay. So therefore here now again the same story, no. Therefore first of all you have to calculate the acceleration here now. Acceleration is nothing but a total net force. What is the total net force now? This is only making to pulling, no. This is not making any pulling onto this one, no. So therefore total force is nothing but a 2 mg only. Clear? By total mass, no. Total mass is how much now? 2m plus this is m plus this is your suppose this is your disc is there, no, moment of inertia. So moment of inertia of the disc, no. Therefore I is equals to mr square by 2. So therefore here it will be m by 2. You can write it now, right? This is m by 2. Clear? So how much now? It will be 2 mg divided by this is 3m. So 6 plus 1 7 m into 2 get cancel out, no. Therefore 4g by 7. So acceleration is nothing but 4g by 7. Therefore this is your answer after this. Clear? So how to calculate the tension now? I got the acceleration here now. I got the acceleration here. Use the equations here now. Therefore downward force is how much now? 2 mg. So 2 mg minus tension T2 is equals to 2 ma. Clear? So this side tension now. Therefore T1 is equals to, so therefore ma. So substitute these values now. You can get your answer easily. You can able to solve the problems now. Right? Right, students. So thank you. Thank you for watching. Like this you can able to solve the problems of the torque and very quickly, you know, right. So these all the topics now which are covered, right. Go through it thoroughly, right. Thank you for watching. Watch remaining other videos also. So please subscribe to my channel now. Thank you.